Last time we talked about AI perception, making an AI able to see us. Today we're going to complete that by making the thing that you're seeing right now. An AI that'll actually look at us, but more so than that, it'll shoot at us. But it'll shoot at not where we are, but at where we're going to be. So to just immediately get started, open up your enemy character and add a new event. We're going to add an event tick. This will run every game tick. First and foremost, before we do anything else, we're going to add a branch by holding down B and just clicking. We add a branch because we need to check whether or not we're actually inside of the enemy, because it shouldn't always be rotating towards us, only when we're inside its sight radius. So to do that, we get a value as bool, and that'll return nothing. But if you turn off context sensitive, you can then get it from the blackboard. And we need to put in two things, a blackboard and a key name. So we can get the blackboard, if I spell it correctly, and that'll go into the top slot here. And then we can make a literal name, and that'll go into the key name. And what do we put into the literal name? Well, last time we made a key, can see player, in our behavior tree. So just go over and copy that, because it's very important that it's the exact same text, and put that into the make literal name. And then that goes into the condition of the branch. So now if that's false, we do nothing. But if it's true, we set the actor rotation. And here you can do it very easily by just using find look at rotation. We're going to do something a little bit more fancy, because we're going to drag over the delta seconds and we're going to type our interp to constants and just put this to the side a little bit. Here we need a current rotation, a target rotation, and an interpretation speed. So this interpretation speed, it really depends on the scale of all your characters and what your game is like. I usually find that somewhere between 75 and 100 works fairly well. So let's go with an 80 here. The current rotation is very easy as well, because we can just get the actor rotation. Again, if I can type properly. We get the actor rotation and put it into current. Now, the target location is slightly more complicated, but not really, because here we find look at rotation. We plug that into here, but now we have two more things to fill in, right? Well, no worries, this also is very easy, because we can get the actor location, and that is all we need to do to plug into the start here. If we then copy over the actor location node again, we can also plug something into here. If we don't do it, it'll just use itself as a reference, but for the target, of course, we want a player character. So we can get the player character. If you wanted to shoot at another like AI enemy, you're going to need to get a reference to that. For the time being, that's not relevant, but do know that you can use this for more than just the player character. It's just a little bit more of a hassle. So then we put that into the target, and putting that into the new rotation. That's literally everything there is to it. If we now go into the game over here and we get into the sight of one of these characters, it'll start turning towards us, but at a speed where we can... I also had a cast fail for some reason. At a speed where we can actually outrun the rotation, so we can free ourselves of the sight, which is, for gameplay purposes, just a very good thing to have, right? So that's the easy part. Now we're gonna get into the enemy having to shoot us, and there's two parts to that: the spawning of the bullet and the prediction of where our player character is going to be. So let's start with the bullet, right? Because we do need a bullet. So let's just make one. We can make an actor. We can call it enemy bullet. And if we open that one up and have it on the right monitor, we can let's add a static mesh here, because we need to be able to see the bullet to dodge it. So let's make that a sphere. Let's make that a sphere correctly spelled. It's a little bit big by default here, so I'm going to make it a bit smaller. And we're also going to add a projectile, we don't need to say add there, projectile movement component. And we're going to set its initial speed to 1. You can also set the projectile gravity scale to whatever you need it to be, either 0, 0.1, something like that, depending on whether or not you want it to have heavy gravity or no gravity or a little gravity. I leave that up to you. It really doesn't impact the rest of this tutorial whatsoever. So back into the actual character, we're going to make a custom event, and we're going to call it shoot player, because that's what we're going to do. We're going to shoot the player. And in order to do that, we're going to need to spawn actor from class. And the class that we're going to spawn from, take a guess, is going to be the enemy bullet. Collision handling override, you can say always spawn, ignore collision, because otherwise maybe sometimes it won't spawn because it thinks it's overlapping with the enemy itself. So just make sure that it always spawn. Now, dragging off this pin, we can get the projectile movement component. And from that, we're going to get its velocity. As you might have been able to see already, I've made a bullet speed variable here. So we're going to drag that one in as well, because we're going to use that by multiplying the vector by the bullet speed. The vector is a very small number here because we set the initial velocity to 1. And the reason we did that is so that we have it traveling in a direction, even if it's very, very slowly. Then the actual speed is going to be set by the character of the enemy here, because the enemy actually needs to know how fast the bullet is traveling. And if we set that inside the bullet itself, the enemy is not going to know that. So that's why we do it this way. And then after we've done that, we're going to get a set velocity. And we're going to plug the answer here into the set velocity node so that it's actually moving fast enough to be a proper bullet. That's the spawning of the bullet, but it still doesn't have a direction. And we're going to get into the transform now. So we're going to split the structure pin for the spawn transform. The scale is going to get actor 3D scale, so that it's always going to match whatever scale our actor is at. The transform location is going to be equal to this shooting direction arrow, which you can just make by saying add arrow and then place it wherever you want to shoot it from. If it needs to shoot from like above its head, you can put it here. If it needs to shoot from its feet, you can put it here. Generally, I would say somewhere around the neck or chest is probably a good place to shoot from. So I've got my shooting direction arrow over here, and we're going to use that get world location to use as the source from where we shoot from. Now the only thing that's left is the rotation, and this is the interesting bit. We're going to copy this shooting direction arrow over here, and we're also going to actually copy over the world location, because that world location is going to go into a find look at rotation as well. We can just hook up this into there, because this is going to be the eventual rotation we're going to be using. And then we're going to do a little bit of interesting math. Don't worry, I'll take you through it, because we're going to start by getting the player character. But we can't just get its world location and put it into here, because then we'll be shooting at where the player is at the moment of the shot, instead of where it's going to be on the moment of impact. So we need to do a little bit of prediction here. We're still going to get the world location of the capture component, not the mesh. It doesn't really matter that much, but let's go with the capture component. And we're going to add a little bit to that. So we're going to add, let's say 80. The reason we do that is because otherwise it's going to aim towards the center point of the capsule component rather than about like eye height. And then we're going to do an addition. But what are we going to add to it, you might ask? And this is where things get very, very interesting. Because we type a get distance to, the target is going to be self, other actor is going to be the player character. That distance is then going to get divided by our bullet speed, because this way we know how far the actor is away, we know how fast the bullet is traveling, so we then know how long it'll take the bullet to get to the actor. But we don't know how the actor is moving yet, so let's also get that, because that's very easy. We can just drag up the player character and get a velocity. If we scroll down all the way down, we get a get velocity, and from the get velocity we just multiply that by the amount of time that'll take the bullet to reach the player. if we add that to the current player location and we put that into the find look at rotation, we've done our predictive movement. If you find it too easy to dodge some of these bullets, because it's very easy to dodge them, since when they spawn, if you stop moving, they will just move to where you were going to be if you kept moving at that pace. So to make it a little bit more difficult on your players, you can multiply this by, I don't know, like 2 or 3, so that it'll shoot at where it expects you to be halfway there. Now the only thing we still have to do is add that back into our behavior tree, because this is what we made last time. We made something that would wait and then do an action. That action is going to be made right now. So we make a new action based on the base blueprint, and we're going to call that, well, let's also call it shoot player, why not? And as always, we're going to start that by an event executes AI. With the control pawn, we're going to cast to our character moving, or whatever the name of your enemy is, and we're going to trigger the shoot player event. After that, we're just going to finish execute, tell the game that it was a success to execute this, and then back in the behavior tree, we just add the shoot player task, and that'll be that. We're running into an interesting issue here, and that is that the bullet is actually blocking the sides of the AI. So that is something that I had not taken into consideration up until now. So let's open the enemy bullet again, go into the static mesh, and go into its collision. And for now, just set it to no collision. You can also set it to overlap. Let's set it to overlap, because if you're going to use this as a bullet, it'll damage on overlap, so just set it to overlap all. That's what that's all like, and until the next time, that is all I have for you as far as shooting AI goes. So we'll get into some more fun stuff with AI at some point in the future, I'm sure. For now, you have a fully functional shooting AI.